Okay, questions about number 1? Yes, no?
Yes.
So it wants you to find the median. The median is always going to be the center point. And so out of these, the mid, I don't know how many there are, 200. So you'd want to find the 100th person, which would be in this category here, 60 to 66. So D. Because if you have 200 people, the median is the 100th person, and which is in the category 60 to 66. Where did 2 go? Oh, I need to view it as 1 page. Okay, number 2, questions about that? Okay, number 3.
Why?
Number 3, a well-designed experiment should have which of the following characteristics? It needs random assignment. It doesn't have to have a control group, or at least 2.
Okay, so I said it didn't, and so I put 1, like it didn't have to have it.
Mm-hmm.
So I said 1 and 3, because like you have to have those 2.
Is the answer E?
Yes.
Okay.
So, like you don't have to have a control group.
But so in this, it says a control group or at least 2 treatment groups. So what that means, why this one is a must, is because you can't just have like 1 treatment group. So the options are you have like a treatment group and you have a control, or you have treatment. But you have to have 2 of something, otherwise there would be no split to compare. So you don't have to have a control group, but if you don't have a control group, you have to have 2 treatment groups.
So if it didn't have the like at least 2 treatment, like if it just said control, it would be 1 and 3.
Mm-hmm.
Right? Okay.
Okay, so it says if 2 candies are randomly drawn with replacement, what is the probability they are the same color? So the probability of both candies being brown would be 0.3 squared. Probability of them being red is 0.2 squared, 0.2 squared, 0.2 squared, 0.1 squared, and then you add them all up. Because it says with replacement, so that means that they're independent. And what is the answer for that one? B, 0.22. Okay, number 5. Each of 133, 3 different were available. In a test of independence, which of the following is the expected for 2-year-olds who select a yellow pencil? So that's when you do row total, column total over grand total. And we're doing this cell right here. So row total would be 14 plus 28, 42. Column total, the whole thing is 133. The column total would be, let's see, do a little mental math here, 65. And so then row total is 42, column total is 65, grand total is 133. And that would match.
Is that the formula for all expected values?
Not for.
Oh, I didn't even need to do all of that. I just needed to do this. Look at the problem.
Not goodness of fit.
It's not for goodness of fit. Goodness of fit is N times P. But then for homogeneity and independence, it's this row total, column total, grand total. Okay, so 52% of all recent births were boys. In a random sample, 49 and 51. So these numbers are so close together that it doesn't give me evidence to change my view or change the hypothesis that 52% were boys. Like this is the population number, I guess.
What's the cutoff?
Or I guess it would be proportion. There isn't necessarily a cutoff. It depends on the p-value. And it doesn't want you to do any math in this problem. It wants you to know that if it's pretty close to it, then it's going to be because of sampling variability. And then if it's not close to it, if it's far enough away, then that gives me reason to reject. Okay, but it'll always be a number super close if it's a question like this. This one. Number 8. So it says there is a 30% chance of a flight being delayed because of icy weather. So, probability of delay, icy weather, that's just how I'm writing it, equals 0.3. If a flight is delayed because of icy weather, there is a 10% chance the flight will also be because of a mechanical problem. If the flight is not delayed because of icy weather, there is a 5% chance that it will be delayed because of a mechanical problem. If one flight is selected at random, what is the probability that it will have at least one of the two types of delays? So, thinking about this, there's two outcomes. You're either going to have a delay because of icy weather, or you're going to have a delay because of why? Mechanical problems. So, two ways that we could have a delay. We already have the probability of it being delayed because of icy weather. It's given to me in the problem, which is what? 0.3. The second sentence that it gives me is the 10% will be delayed because of mechanical problems. I don't even need this sentence because that is whenever it's both. And it's just asking me at least one of the two. So is there to throw you off? So then the other scenario could be, so probability that it's icy is 30%. Now I need to find the probability of mechanical. So I'm going to use this sentence that says, if a flight is not delayed because of icy, then there's a 5% chance that it's because of mechanical. And so if this is a conditional probability where it's the probability of mechanical given that it's not icy, so icy complement. So probability that it's mechanical given it's not icy. And the formula for that, and it's on your formula chart, would be mechanical and not icy divided by icy complement. This whole thing equals 0.05. We also know icy complement is what? It tells me in the problem, yeah. What's the probability of it not being icy? Not 0.3, but 0.7. When you take 0.7 times 0.05, you get this number right here, which ends up being 0.035. When you add these two together, you get 0.335. This was one of the hardest ones I've seen. If you're like struggling to even begin it, my suggestion would be skip it and then maybe try to work it at the end, but don't spend a lot of time on something like this. Yep.
How do you know it's not just like straight 35? Like, because originally I was going through, I knew it wasn't anything else besides. I knew it was like in the 30s.
Because I solved for this number.
Is that just because there's an intersection between the mechanical and icy?
Mm-hmm.
Okay.
How do you find 0.7 again?
So it's 1 minus 0.3. So it's either delayed because it's icy or it's not delayed. Number 10, if it says binomial indicates that you have a fixed number of trials. You need two mutually exclusive outcomes, and they need to be independent of each other. So one outcome does not affect the other. So if I'm reading through that, all games were played by the same player whose skill improved. A is wrong because the probability, it needs to stay the same. So I guess that's another one. Like, probability is constant throughout the fixed number of trials. So like flipping a coin, the probability never changes. So skill improved is what makes that wrong. B, a group of 5 players play 20 games in a row. Well, there's more than 2 outcomes with that one. C, it says until they had lost 3 games. That word until makes it geometric. If y'all remember that. Like you keep going until something happens. D, 2 players of equal skill level play 1 game a day for 50 days and their skill level did not change. So it would be D. And then this one it says until, so that's what makes it wrong. Does that help a little bit? So number 11, it's like the more that you have, the lower your chances are for rolling or getting a 1 or 2. Because you're just adding more and more and more chances of not getting that. Because it's already a really low probability. So by adding more, it's making it worse.
2 6 times 2 6 times.
Yeah. If you keep adding more dice, it's just making it smaller because it's a fraction. You forgot about switching the stem and leaf like this scale. So for female, from 6 to 14, it would be a left skew. But remember, if it's like on the left side, imagine having to flip it. It's also a left skew. I don't know if anybody missed this, but they'd both be skewed to the left. Is that D? Is that what the answer was?
Yeah.
Okay, that's what I thought. So, it creates a 90% confidence interval. The word proportion here, so you're going to use proportions, P. What is the smallest sample size? No more than 6 percentage points. So 0.06 equals Z star of 0.95. So the Z, I think it's 1.645 square root. Then they don't give you the proportion, so we assume that it's what? 0.5, 0.5. Or you could just go ahead and put 0.25.
Wait, do you go halfway to 100 or no?
Yes.
So it's not, it's 1.6. Wait, yeah, sorry, I thought it was 95.
So it's 0.5 times 0.5. I went ahead and just replaced it with 0.25 because it's going to be the same every time. Then you divide by 1.645, square it, then take 0.25 divided by that. Basically, you're just solving for n. I keep it all on my calculator. And what do you end up getting? Does anybody know the exact number that you get?
It was like 186.
186, maybe? And so then you would choose 200 because you choose the one that's closest to it, but it has to be above. So if you have more area on the tails, then there's a larger standard deviation than in the middle. Okay, 10 tags numbered 1 through 10. A second box contains 8 tags 20 through 27. The different number on each tag. One tag is drawn at random from each box. What is the expected value of the sum of the numbers on the 2 selected tags? First one, so the expected value of the first one would be 5, right? 5.5 because it's in the center. Because it's 1 through 10, so the midpoint of that is 5. Like, the expected value for the first set of tags is 5.5. The expected value for this one would be 23.5. And then you just add them together to get 27. 29. Yes. Thank you. So expected value just means mean, and when you're combining means, you just add them together if you have 2 sets of data.
And 1 minus B.
Yeah.
Oh, so yeah, when you check the conditions,
Is that only for Z that you do this?
yeah, only for Z. So you gotta check the conditions. Yeah, the answer, it would, so if it doesn't meet conditions, then you say that it's not valid. And that's true for any multiple choice question, because remember on the chi-square test, I think one of the questions, the expected counts were less than 5, so you would say the chi-square test was not valid. So anytime on a multiple choice test, if it doesn't meet the conditions, you say it's not valid. Is the z-score formula, so you should do p hat minus p, or x bar minus mu over the standard deviation, which is p1 minus p over n square rooted, right? Oh no, this is a mean and standard deviation. I don't even know what I'm doing. This is a x bar minus mu over sigma question. So 2.3 minus 2.
Oh,
I think it's
2 minus
it's 2 minus 2.3 because then
Because 2
Oh, x bar is less than 2. So
Wait, so then
I think they have to break up the sigma into like standard deviation.
Oh.
mm-hmm. Because the standard deviation is over the sample size.
yeah, I put B.
That gets you what formula again?
Standard deviation,
No, the total thing. The x bar minus u.
the z-score, or
That's
the
z-score.
the test statistic in this case, but it's the same formula as a z-score.
So wait, sorry, what is this again?
This is the test statistic or the z-score formula. So you're combining the standard deviations, which is always like square root of the standard deviation squared. But it gives you the variances already, and variance is just what compared to standard deviation? Standard deviation squared. So it actually gives me these numbers already. So since it already gives me the variance, we don't need to go back and square root it and then square it again. We just input the variances.
What's the formula? Oh, it's 2. Why do you divide it by 12 again?
Well, it gives me the variance in the problem, so I'm just taking what it gives me in the problem. Yeah. Bias could be when you have a convenient sample, you don't randomly select. So that's under the same kind of, like if you see sampling bias, it's the same thing as convenient sampling bias. Which of the following biases is most likely to have occurred in the poll? It would be non-response
It's
because,
response.
or wait, hold on.
I think it's response.
Well, why would it not be?
I think it's a poll. Wait, what's the difference between response and?
You put non-response and you got it wrong. 22 is the z-score formula for 33%. So above which 33% of the scores fall. Above, which means I use what for my percentile?
67.
0.67, but you don't choose just 0.67. You want to find the z-score of that. So inverse norm of 0.67, 0, and 1, and I think you end up getting 0.44
Yes.
equals x minus 78 over 8.6. Yeah, so they put the 6.7 there to mess with your head. These need to be z, like z equals, and the z-score at the 67th percentile is 0.44.
So when it says above A,
The other half,
or the
Yeah, like if you have your normal curve and you want 33% above, then you're at the 0.67 percentile.
so it's A.
No, it's D. Okay, 23. 23, you should have gotten this one.
No.
Just determining what the p-hat was and the z-score. 24.
RTS.
Okay, this one gives you a z-score of negative 0.1, first quartile, and 20th percentile. So R, S, and T. We're gonna convert them all to percentiles. T is the 20th. S would be what percentile? 25th. And if you have a z-score of negative 1, then you could do a couple things. You could use the empirical rule, where if you're at negative 1, how many? The empirical rule, if you're 1 standard deviation away, how much percent is that?
How much percent?
Yeah, 1. How much?
How much percent? 1?
68.
it'd be
Yeah.
40,
So then you're going to take 34 by
Bye, Sabine. Have a great day. 68.
68, 95, 99.7. So if you go one below, you're going from the 50th percentile and you're subtracting 34%. So you're at the 16th percentile. If you don't want to remember that, the other thing you could have done is normal CDF of negative infinity to -1, 0, and 1. And that would get you
So is Z-score, is
0.16.
that just how many standard deviations?
Mm-hmm.
Okay, I got lucky there.
So then it says from least to greatest, so it'd be R, T, and then S.
I got lucky on
Yeah, maybe.
Yeah, I kinda just guessed.
Everything includes sample mean. So if you see sample here, no.
Yeah, I crossed that one out first.
These don't make sense. You want to choose the if we repeatedly sample ones.
Do you have another set? Do you-
Always?
Mm-hmm.
It's always.
Mhm.
if we repeatedly-
Yep.
And it would include the population mean.
So never sample. So if it says we repeatedly sample, whatever, we use that, not.
Mm-hmm. Because 2.5, here we have sample. Here it uses the word sample. So you want to choose the one that is projecting towards the population. So median's at 55 and it's a left skew. Which one of those displays that?
Deary.
It could be D or E, but does it have any outliers in the box plot? No, and then there would be an outlier here.
How
So
about outliers shown in the box?
Wait, how's that?
there's just a dot.
How do you
Oh,
know
That's
that?
not an outline,
Yeah, you don't know that's an outlier.
It's more of an outlier than this one.
but it's
This one
still
doesn't have
contained
any.
in the fence.
Yeah,
Yeah, it's still a min 35 and max.
that could have been either.
You can look at how far the IQR is. Though.
Yeah, you'd have to calculate it.
Yeah.
Well, even
If you
did,
wanted to
can look
calculate
at
it.
how wide that box is, and like most of them are going to be. I don't know.
Like if you look at the 25th percentile, which is the first quartile, where is that? 45. So if it's at 45, this one, it would say that 25% are less than 45, which doesn't make sense for E, but it does for D. What did I tell you guys about this little, for match pairs, this little guy right here,
Mass pair.
that makes it a match pairs. So if you have, because it's saying swimmer 1, time before, time after. So if you see a chart that has 2 lists, and there is a row above it that indicates that that pair, that swimmer, or that grocery store, or whatever this is, gets both treatments, then that means it's a match pairs.
I mean, I did put that, but like it was the wrong one.
So it would be paired, so we get rid of these.
I put it.
And it says the difference. Wait, hold on. Let me read it.
I got it.
Before, I just saw the word difference. I didn't read it all. So you want to do, you want it to be greater than because you want the shaving to increase or help your time.
Because she already dropped her to those.
So if you're doing before, after minus before, you want that to be positive.
Yeah, but I'm missing.
Based on the confidence interval, which of the following should the newspaper report? So 95%. There's a 95% chance that Smith will win. That's not true.
What is that?
The poll predicts that Sam will win, but there's a 5% chance that the prediction is incorrect due to sampling error. I'm gonna skip that one. There is convincing evidence. No, there's not a 95%. Like you don't mix the 95% confidence and convincing evidence.
Yeah, what is that plus or minus? 0.5.
So this is saying like there's, yeah, so the margin of error, so it's from 0.48 to 0.56. Well, if you go down to the bottom part, 48% means he wouldn't win. And then 56% would mean that he would win, but 0.5 is contained in there. So we could not make a prediction with 95% confidence.
Oh my goodness.
So E, does that have to be greater than 0.5?
Well, and also you can't make a prediction. So like if they were both over, if it were like from 0.52 to 0.56, then you could make a prediction from that because they're all over 50%. Like it's all of him winning. But here we don't know. He could either win or lose with these numbers.
Win or lose, I'll
So
be
we
with you.
can't make a prediction from that.
What?
The probability distribution, doesn't it just give it to you? Let me see.
I don't believe so.
No.
Oh, these are all conditional. So suppose that the older has a 50% chance of survival if the older eaglet survives. So if the older survives, the younger has a 10% chance of survival. If it does not survive, the older eaglet has a 30% chance of survival. So if you use the conditional probability, so probability that younger survives given older survives, then it would be younger and older over the older surviving. Are you following like my equation? So younger survives given the older survives. We can plug in, so 0.10 equals younger and older surviving over 0.5, which is the older surviving. When you multiply those together, you get 0.05.
What did you? I don't understand.
And
what you mean.
0.05 represents younger and older surviving, so that would go with the 2, like they both survive.
Okay, no, but I don't understand how you even solve that. I don't know if I understand.
Could you have just done the 0 first?
That like neither of them survive? Yeah, so if you do that neither of them survive,
Because I feel like, well, just because so you can just kind of decide on like an answer, like, because like C and D both have 0.05, so I feel like.
yeah, so if you,
Oh, are you treating that younger and older as one thing, and then you?
like younger is a bird, older is a bird, and then,
Yeah, but you're treating them separate. Like
Yeah.
they're one.
Yeah.
Together.
like this is one, so that they both survive is 0.05.
It's on the conditional thing.
Yes.
formula. That's
So this is like none, one survives, both survive.
Oh, so you do 0.7 times 0.5 to get the 0.5.
Yeah, so then to get that neither of them survive, it would be 0.7 times 0.5, right?
So yeah, it's 0.5.
I'm saying on why younger
And that
older
means-
on the over 0.5, that younger and older is as one thing.
Yeah,
That's what
so
I'm
younger
saying.
survives and older survives, so that means that they both survive.
That's so it's not like why or younger is like its own number and then older is like
No, yeah. So 30, anytime you have linear regression and it asks for confidence interval or test statistic, I think on this next one it's asking about test statistic for multiple choice 3. The formulas, you do have to have them memorized. So for a test statistic, it's B over SB. These are the two numbers you're looking at. And these are always the two numbers that you're looking at. The confidence interval is B plus or minus T star SB. So 0.583 plus or minus T star times SB, so 0.138. You can go ahead and get rid of these 3. It's not over anything. Then the only difference is your T star. So it would be inverse T. My sample size is what? And then you would subtract it from 2. I didn't.
Like 30 and 28 or something.
The sample size is 30.
Oh no, it's 23, so 21.
So sample N is 23. So degrees of freedom is 21. And then you get, I don't know what you get. 2.08. But yes, these two formulas do need to be memorized. They just aren't as intuitive on for test statistic and then confidence interval on a computer output. Has been transformed by multiplying by 3, then adding 10. If the original sample had a variance of 4, what is the variance of the trans? So if it gives you variance, you gotta convert it to standard deviation first and then go back and square it. So it'd be 2 times 3, which is 6. The adding 10 doesn't matter. Then you square it to get 36.
So you square root,
Yeah, if it gives you variance, you need to square root it first to get standard deviation.
and then you take that value and multiply it by 3,
And then the adding 10 doesn't matter.
because it doesn't change,
Mhm.
because it's
So we have a sample of 102 players. Independent, so it's an independence test. And a p-value of 0.001. I did not calculate the expected values. Did you get any that are less than 5? Anyone remember?
On,
Basically, like, is it B?
this one was the D.
Okay, so if you
They're all
find all the expected values, they're all greater than 5, so it ends up.
5.18, but
That's
it's
okay.
greater.
Yeah, it's still greater. So check expected counts first. From there, if they are not, or they all are greater than 5, then you're going to interpret the p-value. So that means that there is evidence of an association between, because we're trying to prove that they're dependent, or that there's an association. And it wouldn't be this, because it's rows -1 times columns -1, so you'd have 3 degrees of freedom. And the null hypothesis would be that there is no association. So that's why C is wrong. So it looks like they did a match pair 85 times. And out of the 85 times, yes. And out of the 85 times that they did it, they only rejected twice. So out of the 85 times, they rejected twice. Out of 85, which is not very many. So if you only reject twice, but you fail to reject 83 times, then the reason why you rejected twice is probably due to some sort of sampling variability. And so it would be C. There's insufficient evidence. Because more times than not, you failed to reject. 35 is talking about overall like a weighted average. And so for juniors, physics has a higher GPA, but for seniors, chemistry has a higher GPA. So when you add these two, or I guess when you average them, like obviously you get 3.3 and 3.0. So it seems like chemistry would be higher. Or I guess, are they comparing juniors and seniors?
Yeah, if you had like a ton of juniors, but just a couple of seniors, then it's weighted.
Right. So if you're doing a weighted average, if you had, like we were saying, if you had a ton of juniors, like if you had 300 juniors and like 10 seniors, then this would account for a lot more than compensating for the 3.6. So by weighted average, that could change the distribution of the averages overall for physics and chemistry. It could happen. Whether it does happen depends on the number of juniors and seniors. So this is just deciding what kind of test it is. So let's highlight some key phrases.
How many multiple choice do you think are going to be on there to ask what type of test?
Like 1 or 2. So first word I see is proportion. So which ones can I get rid of? Mean, t-test, t-test. So now I have B and E. Now I need to see how many samples there are. 1 or 2. How many samples are there? 2. So 2 sample. Where does it say 2?
It says $5 off and 10%.
Yeah, so 2 samples. Okay, chart. So we have,
Oh, were you doing it?
well, I was gonna let you do it.
Okay.
We have increasing
Oh.
alpha. We have increasing sample size, and
Why are
then
all
we
these
have
markers done?
increasing the difference between the ho and the ha, like the difference between those. And then we're gonna say what it does to alpha, to beta, and to power. So if I increase alpha, what happens to alpha?
Okay, I think
It goes up.
I think it.
Beta goes down, power goes up. If I increase sample size, what happens to alpha?
Oh, I
Same. Beta goes down, power. Yeah.
Okay, is that right?
Yes.
Oh.
Perfect.
Thank you, Gabby.
And this would be type 1 and this is type 2 if it's talking about that instead of just alpha and beta. So what am I doing? I'm increasing alpha here. So if I increase alpha, my power goes up and my beta goes down. So D.
It's not deep though.
It's the last one.
Yeah, I put D and it's not D. It's supposed to be.
Wait, hold on. Let me reread this. I read it going from 0.01 to 0.05.
Yeah.
It's going from 0.05 to 0.01.
Because you're.
So I'm decreasing alpha. So it's doing the opposite. It increases beta.
Yeah.
And then it does the opposite. Increases beta, decreases power. So it's E. Tricky wording. So difference between observational and experiment. Experiment means you're imposing a treatment on people. And observation means you're just sitting back and you're watching. So experiment means you're making people do things. But in both of them, they both have random selection or assignment. Is it C?
38.
Yeah.
Yeah.
So with C, they're not randomly assigned, they're randomly selected. And then in an experiment, they're randomly assigned. The word always is what gets a lot of these things. Always is like an absolute that it could sometimes happen, but not always. So the p-value is actually down here, which is kind of weird, but it's greater than, so you'd say there's not convincing evidence.
D.
Yes. And 40? So if it's saying that it's unbiased, that means that your mean always, like the mean of your sampling distribution always equals the mean of your population. So unbiased means like the mean of your sampling distribution equals the mean of the population. That's what unbiased means. Like it's centered at the same value. That's just kind of a definition.